All right, for our last chapter, we're going to talk about probability of events. What's the relationship between the probability of an event and its complement? That's our essential question today. So we're talking about probability. You've probably seen this before in previous classes. It talks about chance and analysis. It has to do with mathematics. We're trying to figure out what's the likelihood of something happening. So we'll be dealing with things like spinners and rolling some dice or flipping a coin or picking a card. All those things typically have to do with probability. Later on in high school and stuff, you'll learn about the standard deviation and normal curve. But this is also probability, like, hey, where does it lie? Most of the people will be here in the middle. There's some that are over here, some over here. But we use this for business and for other reasons as well. But you might as well get to see the bell curve. This is the bell curve that you'll see later on in high school. All right, so let's go ahead and define a couple of words. Probability, it's the chance that an event will occur. And outcome, any one of the possible results of an action. So we're talking about probability. You're going to see it something like this. A big P, and then in parentheses will be the event that you're looking for. Okay, the favorable outcome. So the number of favorable outcomes divided by the number of possible outcomes. Let's take a look at what I mean by that. And before we do that, let's talk about some words that you might be using. So if I take a look at something and it's a 0, right? It's not impossible to happen. We use the word impossible. It's a 0% chance of happening. If there's about a 1 in 4 chance, we consider that to be unlikely. Percentage-wise, it's about 25% or 0.25. If it's half-half, as likely to happen as not is the words that we use, it would be 50% chance. If there's more than that, then we call it likely. That's 3/4 or 75%. And if it's 100%, for sure it's going to happen, then we call it certain. Now, of course, there's some middle grounds in between these, but you can, if it's close to this, you would consider it likely. If it's right on, it's, as likely to happen as not. If it's somewhere close to this, you'd say unlikely. And if it's over here, it's impossible. So our first example, find the P of 6. So the probability of rolling a 6 on a dice, on one die. So if I roll a 6, let's see, well, how many possible outcomes is that? What's the favorable outcome? I want to roll a 6, and how many total possibilities could I have? Well, there's 6 sides to it. So here, it would be a 1 out of 6. Only one number is a 6, so it's a 1 out of 6, or 17% chance. So you would say that is unlikely. Okay, it's unlikely that you're going to roll a 6 on just one roll. Let's take a look at another one. What if I ask you, the same die, and I ask you, hey, what's the probability of rolling a 2, a 3, or a 4 on a cube? Okay, on a die there. So if I'm going to roll that, I could say, well, there's 3 different numbers that I could choose from, or I could do 2, 3, or 4. So that's 3 out of 6, which is 0.5 or 50%. That's going to be as likely to happen as not. Pretty simple. What's what I'm looking for out of the total possible. Okay, and that brings us to our next and the final word here, complementary events. 2 events in which either one or the other must happen, but cannot happen at the same time. Complementary events. So let's look at an example. What's the probability of not rolling a 6 and the probability of rolling a 6? So those 2 together are called complementary because the probability of rolling a 6 is 1 out of 6. The probability of not rolling a 6 is 5 out of 6, right? There's yes, these are all the no's. So together, they're complementary events because that's going to equal 100%. If you say, hey, what's the probability of rolling a 6 or not rolling a 6? Well, I cover all my bases, right? Both of them, so it's going to be 100%. So these are considered complementary events. And here's my last example. A letter is chosen randomly. Find the probability of the event as a fraction, as a percent, and as a decimal. So I've got some letters over here, right? First question is, what's the probability of picking the letter D? So I take a look at these and I say, well, I need to know how many there are total. 2, 4, 6, 8, 9. And then what's the one I'm looking for? I'm looking for a D. There's only one of those, so it's going to be a 1 out of 9, which is about 11%. And that's going to be unlikely, right? Unlikely that I'm going to choose the letter D out of all of these here. What's the probability of grabbing an S, a V, or an L? Well, there's one S, there's one V, and there's one L. So that means there's a total of 3. 3 out of 9 gives me 1/3, or 33%, also considered unlikely. It's not very likely, okay. And the last one, what about not pulling an I? Well, not an I. So I have 3 I's, so 3 out of 9, but that's not what I'm looking for. I'm looking for the complementary event of that. Oh, well, if 3 of them are 9 out of the 9 are I's, then that means 6 of the 9 are not I's. So I would say that's 6 out of 9, or 2/3, which is going to be considered likely. Okay. All right, that's it for the notes today. If you have questions, be ready to ask me.